This question is asking us to find out the EMF induced around the coil, and it has given us a picture of a coil which has 100 number of turns. It has a magnetic field going to the right. And this is an extra diagram given showing the magnetic field at a certain time period. Now to find the induced EMF, we need to use the Faraday's law. Faraday's law tells us that the electric field will be equal to change in the magnetic flux divided by change in time. So we know the formula for a change in magnetic flux, that is NBA cos of theta, where n is number of turns and A is the area. Cos theta, the angle here that the coil makes is 0 degrees, so cos of 0 will be 1. So we can simply write that E is equals to minus NA dB by dt. Now what we can see from the extra graph given to us, that this magnetic field function of time is linear. So the equation of this straight line would be y equals to mx plus b, where we have the intercept of 2t, which slope is minus 2 divided by 0.1, that will be minus 20 t by s. Now magnetic field can be calculated by just putting this in the equation of 20t plus 2 and putting back at our previous equation of E is equal to NA dB by dt, where n is the number of turns, A is the area, and our d by dt minus 20t plus 2. Taking the derivative of this, multiplying by these two numbers, we get E is equal to 2.5 volts. The second part of the question asks us to find the current. And to find the current, since we already have a voltage here, we can just simply apply Ohm's law, which is given by V equals to IR. So it will be 2.5 divided by the resistance given, which will simply be 0.25 amperes. The third question is asking us about the direction. Now, considering the Lenz's law, the induced electric field curls around minus of the magnetic field. So it decreases as shown by the graph. Then B is opposite of delta B is opposite of B. So it should point to the left direction, left of x direction. Also in number D, point P in so the direction is given by the right hand rule.